graphic representation of average and marginal values. In economics, it is common to resort to the use of average and marginal values of a variable in order to analyze thoroughly the economic situation. The average value of a variable is estimated mathematically by dividing the total value that variable adopts by the number of units that generate that total. Therefore, when we talk about average values, we are implicitly referring to unit values because we are allocating an equal part of the total value to each of the units. The marginal value is one of the instruments most used by any economist, for many of the problems that arise are analyzed using marginalist logic. That is to say, comparing what the last unit or marginal unit represents. Mathematically, in terms of discrete or continuous calculation, its value would be estimated as follows. How are the average and marginal values of any variable calculated graphically? To answer this question, consider a function that represents the total value of any variable. If what we want is to estimate its average value, we will draw a radius vector to the start point and calculate the value of the slope of that radius vector, this being the average value of the function at that point. If we proceed with the other points, we will obtain a set of average values that will describe the graph of the average value of the variable. If we want to estimate the marginal values, knowing these are calculated mathematically by deriving the total function, and since any mathematical derivative shows the rate of change of the variable, we must graphically draw a tangent to the point of the total function considered, and calculate the value of the slope of the early mentioned tangent, which is its marginal value. If we repeat this procedure at all points of the total function, we'll be able to decide the marginal curve of the variable.